Hello, here we are. Third video in this refreshed, rejuvenated series where we're making Minecraft or a Minecraft-like thing with Python and using Peter Amland's wonderful Ursina engine. So this is where we got to last time. I think we just switched on some simple biomes by looking at how high blocks are being produced using our Perlin terrain and then deciding to use a different tile set, as it were, from our atlas, our texture atlas. Okay, so what we want to do now is get our terrain procedurally generating wherever we move our character. Because at the moment, excuse me, if I move to the edge of the map, then I'm not getting any more Perlin terrain generated. So just like the old videos, if you watched those, the first version, we're going to procedurally generate things as we move around. But I'm going to use a slightly different system. The basics of it, I might as well explain while I'm still in the world, is we're going to divide our world into subsets. Another word for that might be chunks or parts. And at the moment, we're just looking at one subset, which is far too large. If we try to create these, like, I don't know, 10 of them every single second, and this took about 6 seconds to load, it's just going to slow down our game. So we want to make the subsets as small as we can, something like 4 by 4, and then we can generate them all the time as the game's running, and it won't slow things down. We'll still have our approximately 60 frames per second. Okay, so what we've just got to work out is how do we position our subsets around the player and then keep generating in like a swirl, as well as not generating any terrain where we've already been. Now, fortunately, we've got a terrain dictionary, so we can use a terrain dictionary and say, well, is there terrain there at this position? If there is, don't create a block. If there isn't any terrain there, we can create a block. But first thing we'll do is, can you see the cursor? There's like a little diamond for a crosshair in the middle. We'll take that off, and I think we need our terrain to look more varied. In two senses. One, it'd be nice if some of the blocks were darker or lighter than others, and also I think we can improve our Perlin numbers, our Perlin properties and things. So we're in the main file, the main module. So what we do up the top here, where we're sorting out the window color and things, and we've got our subject there, we'll say subject cursor dot visible equals false. So as easy as that, that should turn off the cursor. And by the way, if you wanted full screen, you could write window dot full screen equals true, and then you could play full screen. I might leave that on as a little surprise to myself, because I'll forget that I've done that in a moment. I'll be like, oh, how do I get out? I should still be able to use Shift Q to collapse the window. Okay, right. We also wanted to add some variation in the color of our blocks. So if I go into the Mesh Terrain module, and let's just remind ourselves, here's our project folder. So we've got the main module, that's where we run things from. We've got the Mesh Terrain module, which looks after building the terrain using the mesh. And then we've got, finally, which we made last video, the Perlin module, which has our Perlin information on. And we've also got this Perlin underscore module file, which you need for the Perlin stuff to work. And that wasn't coded by ourselves, but we need that in our project folder. So we've got 4 modules at the moment. Right, so I'm now in the Mesh Terrain module, and I'm in the right place, yes. So in generate block, this function, this is where we're grabbing our model of our subset. And again, here, we're just using one subset. So I've put in subset 0. Later on, we need to change that to whichever subset we're working on as we're building the terrain. Then we're extending the vertices, i.e. asking for a new cube shape to be at this position. We record that position on the terrain dictionary, and we put in T for the value of that position to say there's terrain there. And then we decide the texture atlas, but the texture from the texture atlas. But what we might want to do just before there is get hold of our model's colors, American spelling, and then we want to extend those. And what we want to do, double brackets, because in here we need a new vector 4. We could use a vector 3 and then just pass in how much red, how much green, how much blue. But if we have a vector 4, we can add another number on the end, which will be the alpha channel, so how transparent you want your blocks. And then we could have like transparent terrain, which will probably be more useful when we do water and things like that. Okay, so we want those values to be kind of random. So at the moment, I'll just put C for colour. So that's how much red, how much green, how much blue. And we want those to be exactly the same number, because if they're just like 1, 1, 1, that means the maximum red, maximum green, maximum blue. So that'd be essentially white shining through our texture. So it'll just look exactly the same as it did before. If I put 0, 0, 0, it'll look black. So as you move from 0 to 1 for our colour channels, it just lightens the tone. So we want to actually say, well, be your ordinary colour minus a random amount. And I forgot the 4th channel, and we'll just leave that at 1, so fully opaque, no transparency. And then it's got to get the right place for my brackets. I think I need to do a comma there, and then yeah, so we've got, there we go. That's what we need first of all. We don't need the second parameter, but I think, do I just need a comma for some reason? I've got that in my prepared code, a comma there. You could experiment and see if we don't need a comma. And then we want to times that by how many vertices, I think it's by vertices, yeah, that we've got in our block. So I know that's going to be 36, but I shouldn't use a magic number like that. So actually we should go and say, multiply that by num vertices, and I'll just write this dot num vertices. So this class property doesn't exist yet, so let's go and make that at the top of our class, at the top of our mesh terrain class. So once we've got our block loaded, that's where we can get the number of vertices. There we go. Number of vertices equals the length of this dot block dot vertices. There we go. That number should be 36. In fact, let's just write print this dot num vertices, and then in the console we should get the number 36 coming out. Or that's a handy way to find out how many vertices are in your model. Anyway, even if we used a different model now for our block, our code down here will work because we've put a variable there. Right, so now we need to generate a random number for C. So we're going to write C equals a random number. So this function from the random module will just give us a number from 0 to 1. Now, if we happen to get 1 or 0.9, something like that, then our color channels will be 0, which means we'll get a black block, which we don't want. That won't look very good. So let's minus half off. So maximum we could have off is half as bright as it was before. So that should be fine. I need to write a little comment so we know what we're doing when we look at this like weeks later. So decide random tint for color of block. Smiley face. There we go. So we know what we're doing there. And this random function won't work until we import the module. So this will already be installed with Python. So we can just write from random import random. That's all we need. Right. Let's go and run things now and see how things are looking. If things are working okay, then we can make some changes to our Perlin Noise as well. And then, yeah, we're doing the important thing. Infinitely generate. Oh, there's the 36 in the console. So there were 36 color vertices as well. Okay, that's looking a lot better. So we've got a lot more variety now. So it looks like the individual blocks are like individual, even though, as we see, we've got like the exact same pattern on all the same faces. It just gives a nice bit of variety, I think. That's great. And we're full screen, and we can't see the cursor. Brilliant. Right, Shift Q. Thank goodness that worked. Okay, I might just take full screen off. So I'll just write false there. There we go. And what do I need to do? I need to go into Perlin. So into the Perlin module now. So let's just play with these numbers. Oh, here's a nice little thing you can do. Let's say you wanted to make the seed out of a phrase or something. Bring the milk. I don't know. Some random thing. That won't work at the moment because the seed needs to be a number. But we can convert from letters, at least, into numbers very easily, or into integers we need. So if we use the odd function, so it's a bit like using int or string, and then we can put in, I don't know, let's just write yo plus odd. So you have to do a single letter at a time. So yo y plus o equals yo. So from there, you'd probably have to write your own little algorithm to translate from a string into, like, break it down through each character and then convert it into that. So I won't do that right now. Maybe I'll do it later if you want me to. It's quite a nice little project. So we've got a different seed. That won't really change the terrain very much, but we want to actually change the character of the terrain. So let's go up to 8 octaves now to get a bit more variety. And then frequency, we might have to go really high. And then because amplitude will beef up to about 24. So that means you can go maximum 12, minimum -12. And yeah, if you're raising the amplitude, you want to really raise the frequency as well, because that smooths things out. If you stretch it too much, you'll have lots of gaps in your terrain, which our terrain generation doesn't mitigate against yet. It's not sophisticated enough yet. I should have made the terrain smaller so that we don't have to wait 6 seconds or so for it to load. Ooh, so it's looking different already. Yeah, I like that. Ah, there you go. So even using 256, I've stretched it too much, so we get these little holes in the terrain. Maybe they'll be useful later on when we do caves and things, I don't know. Turn that bug into a feature. There you go. I quite like that terrain, so you can muck around with that. Okay, so let's get to the main mechanism here. We need to generate our terrain as we walk around. So we're going to need a new module. Well, I guess we wouldn't need it, but I think it's a good idea. So let's get that set up. So create yourself a new text file, new Python file. I'll do that again, working in Studio Visual Code or Visual Studio Code. I can't remember which way around it goes. And then we're going to call this class a swirl engine. And that's just going to control creating our subset positions as the player moves. And then we've already done the code for, well, make a new subset. That's already done in Mesh Terrain. But all we need to do is control where the subset is being created. So we need a new swirl engine. And the first thing we always do is have our initializing function, or our constructor, you can call it, init, and double underscores either side. And remember, the first keyword must be this or self, or whatever you want to call that first parameter. And that just points the class back to the object instance that you've made. I'll just call mine this. What we'll probably need to accept is the subwidth. So our swirl engine, in order to position the subsets, needs to know, well, how big are those subsets going to be? And we don't know how big we're going to make them, so we'll store it in a variable so we can change it later on. So we'll call that subwidth. And then colon. Oh, I haven't saved this yet, have I? So here we are, and we'll call this our swirl underscore engine. There we go. Swirl underscore engine. Save. And then a colon. I was trying to say at the end of there. So now, just like in mesh terrain or any other class, in our Perlin class, this is where we write the properties for this object. So our Perlin noise has a seed, how many octaves, frequency, amplitude. Mesh terrain has what block, what's the texture atlas, the number of vertices, the subsets, things like that. And there's a sub width. So at the moment it's 128. I'm going to make that a lot smaller in a moment. Now sub engine, I guess it can have a sub width. So we'll say sub width equals this parameter that we've passed in. And we'll leave that there for the moment because I'm going to show you exactly how it's going to work using a diagram. That's the plan. So if you're following along, you'll know what on earth is going on. So a sub width, we'll test it with, I don't know, 10. Oh, and here's a note, something to remember. In, where is it? Generate terrain. So what the generate terrain function does, it's very small. It's just this function, which fits perfectly on the page. Oh my God. And my little face is there, which fits underneath there. That's really good. So we've got an X and a Z position. And then we've got D equals half of the sub width. And then we're using this nested loop to iterate from minus D to D. So it's like the player is in the middle of the, let's draw a little, yeah, if this yellow block, if we're looking down, onto a subset, and all of these are blocks, we start at the middle where the yellow block is, then we go to minus D, so that's half the total width, and then half again down, and then we do all of those, then we do those, then we do those, then we do this, and at all of those positions we're creating a block. So at the end we've got a grid, a square of terrain with blocks, and the heights of each individual block is controlled by the Perlin noise. Okay, so that's what that's doing at the moment. And it's using, the position is going to be X plus K. So the K is how far along the subset we've gone, and the J is like the columns or the Z of the subset. But the X and the Z, that's always going to be 0, 0 in our world. So we want to change that as the player's moving around the world. We want X and Z to be different. Let's go back to my diagram. I'm going to use it slightly differently now. So let's imagine that we're not looking at one subset, but each of those squares is a subset of 10 by 10 cubes or blocks. Oh yeah, what I was saying when I originally got here is note that the sub width, because we're dividing it in half, it must always be an even number, else this will go wrong. So if we set this sub width to 11, then we can't divide that in half. We need to divide it into whole number halves, which is bad programming. I should put a guard against that. Whoops. Let's write a little note. At least, this is the least we can do. Must be even number. There we go. C gen terrain. There we go. That doesn't fit onto a line, which is really annoying me, so I'll put that there. So now I need to separate that so we know which we're talking about. So it must be an even number, C gen terrain. So now the reason why it has to be even, we can go down to gen terrain, and then hopefully we'll say, oh, it's dividing in half. And it's got to be an integer. So, okay, so what are we doing? Oh, right. So we need to change the X and the Z. Right. So let's imagine that this is our player position and the first subset position. And this yellow square is made up of 10 by 10 blocks. And let's say our little player walks up. I've got like a little dot I can use. There we go. It's not very clear, is it? And it's a bit too big. So let's say our little player walks along like 10 blocks and gets to there. We want to generate a new block at the top. Or even if we're standing still, we want a new subset to be generated there, and then one there, and then one there, then one there, one there, like that, swirling around us. So what we're going to do to control that swirl is work out an algorithm depending on what direction it's moving in. So the first one wants to be moving forwards or up. The next one wants to go to the right. So we need a different colour. So let's say green. So the next subset position wants to be there. So the first subset position, where the white one is, we're not going to move on the X direction, we're just going to move plus on the Z direction. The next one, we're not going to move on the X, we're not going to move on the Z position, we're just going to move +1 on the X. And the next one, we want to go down, so we're going to move minus on the Z, and we'll use red to keep track of that. So red means down. And now we don't move left, we've got to move down again. Now we can move left. So we haven't got a colour for that, so let's use dark blue. There we go. And notice we're going to move left again to swirl around. Now we're kind of like back to the beginning of our iteration. So this is a whole swirl. We've done up, right, down, down, left, left. We're going to go up, 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 right, 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 down, 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 down. So let's just do that a few times so we get the idea. So the next direction has to be up once, twice, 3 times, and now I want to go right 3 times. 1, 2, 3, and now we want to go down. So that's red. Last time it was 2, this time it's 3. 1, 2, 3. No, it isn't, it's 4. There we go. And let's go again, so to the left. And what we're looking for, the point of making this diagram is kind of like mathematically, can you see a pattern? Because as soon as we can see a pattern, we can write an algorithm to control what direction we should be going in, depending on how many subsets we're kind of counting. Okay, so now I need to go up again, don't I? Oh, so it's not red, that's white. And let's see if we can see the pattern there. So, so going up, actually, the first time we go up, we've got a count of 1, or a run of 1. We only have to go up once. The next time we get round, so the second iteration, we then have to go up 3 times. And the next time we get round, we have to go 1, 2, 3, 4, and actually the next step would be there. So that's 5 times. In other words, if we're moving up, then each iteration, so each time we're asked to go up again, as we're swirling around to create our terrain, is going up the odd numbers. And it looks like it's exactly the same for the green. So the green being our right direction. So when we're moving right, it goes 1, 3, 5. And if you look at the moving down and left directions, on the first iteration, it's moving 2. Same for the moving left, the blue ones. Second iteration, it's moving 4 down or 4 left. So we've got a pattern. In other words, if it's the first iteration for moving up or right, then you've just got to move a run of 1. If it's the first iteration for moving down or left, then the run starts at 2, the first even number. And now we're on the second iteration. So if we're switching from direction or the first direction to the second direction, then we switch to the third direction, and then the fourth direction doesn't switch to a fifth direction, it switches, we loop back to the first direction, i.e. moving up. So then we can say, now we're on the second iteration. So now we can say, if we're on the second iteration, it's going to be the next odd number, and so on. That's the background of how we're going to work this out, so how our swirl is going to work. So what we need is a this dot run, and our run begins with 1. Then we need iterations. It's how many times we've kind of like done a complete series of the directions. So if we've done an up, a right, a down, and a left, now we're back to moving up again to swirl around. So iteration starts at 0 perhaps. Then we need a this dot count. So we need to see, have we done the number of runs we need? So our count will be 0 to begin with. And that's maybe it. That's maybe all we need. Oh, and of course we need a position. So this dot pos, we'll call it, equals, and I guess we could store that in a vector 2. We do want to start at 0, 0, but we could start anywhere, I guess. Right. Vector 2 doesn't exist, so we do need we could use Ursina, so I think it uses numpys or something. From Ursina, import vec2. So we've got that there. So now we need some functions. So we need a move function. And remember, the first keyword in a class function has to be this. And all that's doing is saying, well, whatever our current position is in, I'm just going to grab a black one. Let's say I'm here, then move me to my next position. So it might be like here, for example. Okay. Oh, I know something else we need. We need to store these directions. So we could store the directions. We could do this a number of ways. We could do it like down here in the move, but I quite like to store it as a list of vector 2s. So if you think about it, moving up would be no movement on the x, but on the y, or on the z, but we can translate it to the y, or translate it to the z from the y. That's going to be moving upwards, so +1. If we're moving to the right, then no movement on the y, but we do want to move +1 on the x. If we're moving down, no movement on the x, but we want to go -1 on the y. And if we want to move finally left, we want no movement on the y, but we want to go -1 on the x. And if we plus that vector to our current position, we're kind of moving the block around. Right, so we want this to be a list, and then in this list we're going to have a little family of those directions which we just did. So we'll put these on separate lines so they look nice and tidy. And we can do that in Python because we're inside the square brackets, so that's fine. I don't need a comma at the end. So moving up will be 0, 1. Moving right will be 1, 0. Moving down will be no movement on the x, and when I say down, I mean kind of like towards me, so it's going to be -1. And well, the opposite of up, because up was 0, 1, so the opposite of that's going to be 0, -1. And then the opposite of moving right is going to be left, so it's -1 on the x and nothing on the y. So there we go. We've got our directions for our swirling. So what the movement wants to do is firstly work out what direction we should be moving. So if this dot count is less than this dot run, then we want to, that kind of like means let's say we're moving down here. And so our count, as we've changed direction, would be 0. And then our run needs to be 2. So are we less than 2? 0 is less than 2. So I want to move down 1. And next time we're trying to move again, we can say, well, we've counted 1. We've done 1 movement. Are we less than 2? Yes. So we need to do another one. Next time, our count will be 2 and our run is 2. So are we less than that? And we're going to say no. So we need to do something else. We need to, in other words, change direction. So if you've counted enough movement and we've matched how many we need for a run, now it's time to change direction. So else, time to change direction. So I'll just write a little note, time to change direction. There we go. So we're still doing the run. So we want to say this dot pos dot x. So our current position is going to be, and the dot x means this first component of our vector, our position vector, plus this dot direction dot x. So we want whatever direction we're in. Oh, sorry, I need to get, this is a list, isn't it? So we need to know what our current direction is. So we'll call that this dot CD. CD will stand for current direction. This dot CD equals 0. So remember, when we're counting in a list, the first item or element on the list will be at index 0. So our last one will be 3. Even though we've got 4 things here, because we started at 0, the last one will be 3. So let's just label that with a comment. Current direction. I'll just say from 0 to 3. There we go. And because that's all together, we can kind of see what's going on. So plus our position is being plus our current direction times, and this is where the subwidth comes in, because we don't want our, let's go back to our diagram. So let's say we're up here. We don't want to move from there to there. We want to move from there to there like that. So the movement we're doing is from there to there. So we're moving not just like one movement like that, not just one block. We're going however many blocks is the width or the length of our subset. So that's why we've got the subwidth in here. So multiply that by this dot subwidth. There we go. So that's our movement almost done. Of course, we might be moving in the y direction as well. We don't have to worry about it. All the information of which x and z movement we're doing is contained in our direction list. Position vectors up there. So our position y, yeah, don't get mixed up here like I've done in my my head just now. Our position, even though we're moving on x and z in the 3D world, this little vector 2 has an x and a y position. We'll translate back to that when we're in the mesh terrain. So the second component, in other words, is the y plus this dot cd. Oh, so that's got to be its x, and then this has got to be its y. There we go. Everything else we can keep the same. There we go. So once we've moved, we've then got to say this dot count plus equals 1. So we've done another movement. Else, if it's time to change direction, I guess we could have another function in here. So let's go to this dot change direction. And let's write that above here. So def to define our function change dir. oh, I forgot the this or the self keyword. And so we just need to say this dot CD, so that's our current direction, plus equals 1. Then we've got to check, have we got all the way around? So we want to say if this, oh actually, let's write it in a different way. If this dot CD is less than 3, then you can change direction. Else, it must be 3 already, so we're ready to go back to 1. Else this dot CD equals 0, I should say, the first direction. So that's 0, 1, 2, 3. Okay, now what happens when we change direction? Our run might change as well. Like when we change from moving, when we move up, the run is 1. When we move right, the run is 1. When we move down on this first iteration, the run is 2. And when we move left, the run is 2. So we've got to work out that. At least there's a pattern. So we can write a little algorithm here. Oh, also, if we're cycling to 0 again, then we need to say this dot iteration plus equals 1. Now we can use this number to control the run number. Right, so either way, we've definitely changed direction, and we know what our iteration is. If we're changing direction and we're not going back to the forward or the up direction, we know that the iteration is still the same as it was before. If we've gone down to up, or 0, this first direction, then our iteration has moved up again. So we do need to work out the run. So this dot run equals something based on what iteration we're in and which direction. So if this dot CD, so our current direction, is less than, i.e. if we're in direction 0 or 1, so if it's less than 2, then we're going to be, let's have a look at our diagram, then we're in the odd numbers, yeah. So up, first iteration once, second iteration up 3 times, then 5 times, and it's the same for moving right. Run is 1 on the first iteration, second iteration is 3, third iteration is 5. Okay, so if the direction is less than 2, now we can answer this question. This run equals this dot iteration times 2 minus 1. There we go. And I'll just put this in brackets so it's very arithmetically explicit. So let's just see if that works. So if the iteration is 1, I'm going to double the number, so that's 2. 2 minus 1 is 1. Good, and the run should be 1. On the second iteration, we should have a run of 3. So second iteration, so that's 2 times, second, what am I multiplying? Oh, it's 2 times 2, isn't it? There we go. So the iteration is 2, times 2 is 4, minus 1 is 3, and of course, the second odd number is going to be 3. So you can see how that's working, hopefully. So to get odd numbers, iteration times 2 minus 1. There we go. Else, we can say this dot run equals this dot iteration just times by 2. Because it's going to be 2, then 4, then 6, then 8. Let's just have a look at that. So the red and the blue, yep, 2, 4, the next one's 6, 2, 4. And it's easy to get to the odd numbers. Just times it by 2. There we go. So change direction also finds what run number we need. Okay, so we're back in move. And we're saying, okay, if the count is less than this run, then fine, move us along. Else, if it's time to change direction, well, actually, we need to then say this dot run. Oh no, this dot run will be changed here, but we do want to say this dot count equals 0. So we're going to start counting how many times we've moved again to see if it matches the run number. So once we've changed direction, well, we then want to move. So we're going to use a little recursion. We're going to say then this dot move. There we go. This is different to what I've done before, actually. So if we need to change direction in move, we change the direction, and then we call this function again. But this time, the count will be 0, so it will be less than the run. So we go and run this, and then we won't run the move again. Okay. That feels a little dangerous to do that. Recursion could create infinite loops and things, but we'll leave that like that. That's scary. Okay, so our swirl engine is maybe complete. I was going to say it's just taking some shape, but we've got iteration count, lovely. I think that's all we need. So where are we going to use this? We're going to use this in mesh terrain. So the first thing we need to do is kind of import that module and that class, that object. So from swirl engine, import capital swirl engine like that. Whoops, I've named it with a lowercase s. We should name that with a capital S because it's an object, just like mesh terrain, capital M, capital T. The Perlin will be a capital P. There we go. Right. So that needs to be capital. There we go. So now, yes, inside our initializer, we need to say, let's do this near the subwidth. We're going to say this dot swirl engine, we'll call this one lowercase s, equals capital S for swirl engine. And now we need to pass in the subwidth. There we go. So that our swirl engine knows what the subwidth is. So there it is. The initializer receives a subwidth. So when you first create an object, this initializing function will run. So that's why you have the initializing function. You can kind of see more now how it works. There we go. So we passed in that. So now I've got a swirl engine. We also kind of need to keep a track of which is our current subset. So we'll call it, let's just call it current subset. It's a bit long that though. So our first subset needs to be 0. And I'm just going to copy that. Now let's have a look at our, oh yeah, we can take off the number of vertices debug line. Let's have a look at our functions. So generate a block. So it's going to extend or add to the vertices of our model to add, as it were, the shape of a cube. So we don't want to always work on the first subset in our list of subsets. We want to work on our current subset, which does start at 0. So things will be working in exactly the same way, at least for the first terrain area subset that we create. So that model is going to be the same. That's going to all be the same. That's fine. Right, so that's that function done. So generating a block, not going to change much. But here, generating some terrain is, we need a different X and Z location depending on where the swirl engine's position is. So this, sorry, I'm back in the swirl engine module. So this tracks position of subset being generated, terrain subset being generated. So in other words, to visualize that, it's tracking what are the X and Z coordinates of these as we swirl around the large terrain. Okay, so back to our main our mesh terrain, and we're in the generate terrain function, or gen terrain. So we want to say, well, x is going to be this dot swirl engines dot position dot x. I'm just thinking the next one has to be a y, not a z. But in 3D space, we do call it, it is the z. Well, we don't just call it, it is the z direction. But now we want to say this swirl engine's position, not z, but just the second component of the position vector, which is a vector 2. It's a vector 2, so that's the x and that's the y. Okay, so we've translated from the y to the z, so that's done. So get our current position. Let's just write a note so we know what we're doing. So get current position as we swirl around world. Okay, so D is just how big our current subset is. So we're just making 10 by 10 subsets at the moment, which should be fast enough. Kind of the bigger the subset you can make, your computer can make, the kind of better. How many subsets are we making altogether? Number of subsets 1, so we need to make that really high. Let's go 512 subsets. So now in the initializer of our mesh terrain, we're going to make that number of subsets, 512. So when we're generating the terrain, yeah, we're going to do one subset to begin with. Lovely. And then we're going to generate the subset. We kind of only want to generate a block if a block doesn't exist there. So let's go to, let's say, if this dot terrain dictionary get, now we need to build that string up again. What is it? String x plus, no, it's x first, isn't it? Plus, I wonder if I can go and copy and paste this from somewhere. Should be up here. There we go. Let's copy all of that. It's almost exactly the same thing we need. Let's just put it, use some indentation. Oh my goodness, we're almost done an hour. So if x plus the x position, the y position, the z position, and we've floored all of those, that's correct. If it, we'll say, doesn't equal, so exclamation mark equal t, then you can generate a block. So that needs to be on a new line there. What have I done wrong here? I've probably just missed out, yeah, this parenthesis I haven't done. But now I have. It's still saying this is kind of wrong. Maybe it was that. That goes to there. Oh, I don't need the square bracket, of course. There we go. Okay. That's what you get for, you have to do a little bit of work if you're doing copy and pasting sometimes. Okay, so if we haven't got terrain there already, then we can generate a block. So we just need that little test in there, new, because our player might walk back to a position we've already been to, and so as we start generating the terrain, it might try and generate some more terrain there, but we don't want any there because we've already done that. Okay, oh, our subset that we're generating needs to be the current subset, so this dot cd. There we go. And now, I guess it's time to move the position. So we've done that first position. So now we need to say this dot swirl engine dot move. There we go. So that means we've generated that one. Now we need to move to the next one. Lovely. At the moment, though, this generate terrain function is only being called once from the main module. Oh, this is good news. Once you move back to the main module, it means you're getting closer to being able to run and test things. So in here, we've got an update loop at the moment, which is just, seeing where our player is, and then seeing if we can step up and step down. But it's not doing anything else. And we've got this, I think from the very first video, update the terrain. So we want to actually make this run. Generate terrain, here it is. So it's not in the update loop, it just runs once at the very beginning. So actually we don't need to run that at the beginning, we need to run it in our update loop. So in the update loop, let's just write ourselves a note. Generate terrain at current swirl position. Whoops. So let's get hold of the terrain and then generate terrain. There we go. So that should now take care of itself. It should find the new position where it needs one. Lovely. At the moment, it's not going to create it where the player is walking. It's just going to kind of start at 0, 0 and then just swirl around no matter where we walk. But at least we can test it out. Okay, let's test that out. So we're in the main function, and let's run. How exciting. Oh, and we've used a bit of recursion in there. It's not running yet. The object has no attribute CD. So where did I write CD? Oh yeah, it's current subset, isn't it? I've just written this CD for change direction. So it's current subset down there. I got mixed up, didn't I, with the swirl engine has a CD for the current direction it's moving in, but the mesh terrain has a current subset, which we have to change up here. Yep, I did that correctly here, the current subset. Oh, actually, we didn't update that. When we've created one, so in generate terrain, this loop generates, so it loops over all the blocks that we need, and once it's done that, it can update that current subset. And then we want to move to the next subset position, but current subset, the current subset number wants to move as well. So this dot current subset plus equals 1. Now the problem will be if we go over the number of subsets that we've created, we need to kind of like make a new one. So let's just write a little hack at the bottom here. If this dot current subset is less than this dot number of subsets minus 1, because the first one will be 0, then you can create a new then you can go to the next subset. Else we need to say this dot, let's just loop around, so the current subset will be 0 again. So we're kind of like looping around. We'll leave that there for now. We'll just leave a note to our future selves. Current subset hack. And a little cheeky wink. Okay. Right. Go back to the main module and just see if we can get some terrain moving. At the moment, because we put that in the update loop, where we should be generating one, whoa, so it's not working yet. Don't know what's going on. Every frame, so our frame rate has dropped to 9, So we don't want to be generating one every single frame. And this is a failure at the moment. So something in our swirl engine maybe is not working. Let's go and sort that out. So firstly, let's just say, let's have in our main module a count variable, and we'll say global count, so we can use that inside here, and then we can say count plus equals 1 if count equals, I don't know, 8 or every 10th frame, then you can generate some more terrain. And then we'll set count equals 0 again. So that's counting up. If it hits 10, generate some more terrain, reset the count. But something's going wrong. Right. So let's think about this. So we're going to generate some terrain first of all. So mesh terrain. So generate terrain. Our position equals this position is good. Let's make sure that's floored first of all. So we've got the terrain width, that's fine. We're getting the height. If the current position, it's not X, Y, and Z, it's X plus K, because we're going through the rows and the columns. So it needs to be X plus K. Y is going to be just Y, because that's determined from the Perlin noise and it's just Y. But the Z needs to be plus J, and that's already floored. I bet that was probably our bug. Let's go back to main and run this and see what's going on. Okay. Oh no, I fell down. Oh, that's not good. Right. Let's, before we run it, we'll just say terrain, generate some terrain. So we've got some terrain to land on at the start. Okay. We've got some terrain. But we're not swirling. We're not swirling. Oh, maybe our iteration needs to start at 1. Let's try that. So in the swirl engine, yeah, because we'll already have one. So what will that do? So if we go to move, if this count is less than the run, then yeah, we get a new position, count goes up, then we carry on. Next time we go in there, the count will be 1, and our run is actually 1 to begin with, yeah. So we'll go to else. So the count is 0, change direction. So we'll go to change direction. If this current direction is less than 3, which it will be because it'll be 0 at the moment, so now it's going to be 1, so it means it's moving right. Go down to here. Oh yeah, to determine the run. If this CD is less than 2, our iteration, was 0 before, but now it's going to be 1. 1 times 2 is 2 minus 1. Okay, that's now all correct. So go back to main. I've got like 10 seconds before it's an hour long video. I really thought that would have sorted it. Hopefully I just didn't save. Control save, go back to main. Oh no, it's still not working. Oh, no. So I can fall off, yeah. Why isn't it working? So let's have a look in mesh terrain where we're building it. So in generate terrain, X equals this swirl engine position X, this swirl engine position Y. Just make sure we're changing those. Yep, this position, this dot pos, plus equals this direction, this current direction, multiplied by the subwidth, this position, yep. Oh, it's plus equals. It's the current value plus the new arithmetic, if that makes sense. Oh, well done, as I like to say. If you forgot that, if you spotted that bug, well done. And it was the bug. Now we're getting. Can we go and find the swirl? Yeah, you can actually see the terrain generating. There is a bit of a jolt actually, which I'm sure in my testing I've made it 10 by 10, and it's running nice and smooth. So I don't know if I'm doing something wrong. But there we go. So if you leave that running, you'll have a massive terrain. Okay, so let's just go and fiddle over a few things. Firstly, and well done by the way, we got it working. A few bugs to sort out. It's always nice. So subwidth, let's reduce that to 4 by 4. And maybe we don't need as many subsets. Let's just say 128. Back to main. How does that affect our speed? Okay, so we've got close to 60 frames per second. That's good, and we're getting some terrain. So now we can try and make the terrain generate a bit faster. So in main, if we make this number lower, so maybe every other frame, we'll generate some more terrain. And what's the speed like? Okay, it's between 30 and 54, it looks like. So that's running a lot faster. Now, I guess what we should just do to finish the video, since we've gone over an hour anyway, is we just need to say, well, start swirling again from the position that the player's in, if we've kind of got to the end of the map. So we've done all the hard work. It's just start swirling again from this position, like you did from 0, 0 at the start, if the player has traversed enough of the map. And then we won't be able to fall off like that. Right. So we kind of should do this properly in the mesh terrain module. And we should do all of this in there as well, but let's just do this very quickly, see if we can do it in 5 minutes. So we want to say if the subject's X position minus your previous X position, so I'll call that PX, which doesn't exist yet. Let's make it just above the count here. We'll say PX equals subject's X, and then position or previous Z equals the subject's Z. So the difference between that, but we want that to be an absolute number. So if we happen to be at 3, and then our previous one was 17, that would be a negative number. But we just want what is the basic distance between those. So if you wrap that in absolute, it will just say take off the minus sign. So if that distance is greater than, I don't know, if we've moved 4, or, and again, absolute subject.z minus pz, and I'll just squash those up so we can fit on the line, is greater than 4, then we want to record what our current position is. So px equals subject.x, pz equals subject.z, and now we want to reset our Swirl's engine's position. So, oh, this is going to be horrible. This dot, no, get hold of our terrains, swirl engine, dot, we kind of just want to say reset. There we go, reset, and then pass in, I guess, px and pz would be the quickest way because they have just recorded the subject's current position, and that's where we want the position of our new subset to be. Right, so let's go and write a reset function in Swirl engine. So here we are in Swirl engine. We'll write this down the bottom. Def reset this. Oh, and now we want to take an x position and a z position. We want to say this dot pos equals x equals x. This dot pos dot y equals z. And now we want to reset our current direction and all of that. So let's put this up here. Actually, to save all of this room, let's just do all of this together. In here, there we go. Run, iteration, count, and current direction all need to be reset. And that means after we've created the position vector, we can then say, go and run this reset. And then we don't have to write all of that in 2 different places. So it means our swirl engine is less than 50 lines, which is nice. Right. So let's just see if this works. So, so I'm back in main, in the update loop. Oh, px and pz don't exist, so I need those to be global. Px, pz, and we just need to say change subset position based on subject position. Okay. It's almost 1 hour, 10 minutes. Let's just run this. I'm going to have to, as long as it's not too buggy, too buggy, then I can, oh no, X and Z, where's that? In this reset, X and Z. X and Z. Let's just have a look. So that's going to be in, Swirl engine. When we've called this reset, we need the X and the Z to be 0, 0. We want to start at this position as X and 0. Right, let's try running that. Even if there's a bug, I'm going to just have to leave that as it is for now. Okay, so it's running nice and quickly. And if I, oh dear, my little buddy there is having a bad time. So this seems to be working fine. Right, thank you very much for watching. I'll see you next time. Goodbye.